When you have qualitative data, you summarize the qualitative data using descriptive statistics. When it comes to the measure of central tendencies, we had mean, median, and mode. The mode is the only one you can use with qualitative data. It is going to be the one that has the category that has the greatest frequency. You can also use mode with quantitative data, but it's not as helpful for quantitative data because you're not going to likely have exact numbers that match unless you have discrete, so whole numbers, integers, counts, as opposed to measurements where you could have fractions. You're unlikely to have multiples that have the exact number of the exact decimal places. So central tendency for qualitative data, we're going to do mode. Now, when it comes to mode, we were in our previous video looking at some of these visual representations in Excel. We are creating pivot tables. So just to recall, we did insert, excuse me. In our original data set, we had our data here. We did insert and inserted a pivot table. We also looked at creating charts using our pivot chart here and insert. And so once you have this information in a pivot table, once we have our frequencies, our counts, we can see the mode. So if we're looking at all genders, then here you can see the grade was the most important to those who identified as male and female children. When we add in, so we'll just get rid of that graph here and this graph here, and let's go back to what we had before. So we have here, so what we've done is we have preference in the rows. We have the part that my face is covering up is that we have gender in the columns. Either one can go into values here. Then when we do that, we can see that for those who identify as boy, the mode, the most common choice is grade. And for those who identify as girl, the most common choice is again grade. So we can see the mode here for both of our genders that we have here in terms of the priorities. So you can get that information once you've created that frequency distribution table. And it's really easy to create a frequency distribution table in Excel by just doing insert pivot table and then dropping your categories here into rows and columns and values. Now, when it comes to variability, we talked about this previously. We use what is called the index of dispersion to look at our observations and the breakdown of the categories, right? So does everyone fall into one category? So did all the children pick they want to be popular, or is it equal between the three categories, 33% into each? The index of dispersion is 0 if all the observations are in the same category, so 100% chose popular. The index of dispersion is 1 if it's equally distributed, so we have three categories, 33% each, and so then you get a number that's in between. Now, when it comes to the index of dispersion, you probably haven't heard of that because it's not very well used, partly because it's a terminal statistic. It doesn't get used in other calculations. Means, standard deviations, we use these because we can put them into calculations later for doing our inferential statistics and hypothesis testing. The index of dispersion doesn't really have that capability, so it's really not that well utilized. Plus, the question is, what does it really add? Well, do you really need an index of dispersion when you can see? I'll just go back and change this to percentages here. Let's see, percentage of column. If you can see that percentage breakdown. So likely you don't have, 20 different possible responses to a single variable. Right here we have 3, grade, popular, or sports. And so we don't really need the index of dispersion to clearly see how it's broken down. We can see that just with the relative frequencies. So the index of dispersion really is only valuable if you have lots of different possible responses to a single variable, where it's much more difficult to see the breakdown, as we talked about, for example, like this pie chart here, there were 10 different possible responses. So then the index of dispersion adds value because it's not as easy to see that variability simply here, that everything is kind of close to 10%, except for a handful of them.